Hey guys, it's Mr. Eisnes here. We are going to start our notes on chemical equations and specifically balancing those equations. Okay, so here we go. Chemical equations, this is a chemical equation down here, and it's just going to help us make things easier to read. Okay, so we have all of our chemical symbols, we get from the periodic table. We have our coefficients, which are going to be like the sixes here. The big numbers out in front are coefficients. The small numbers are actually going to be subscripts. Okay, we have all this information, and all it's doing is helping us understand what is happening at the atomic level in this reaction. So right now we have carbon dioxide gas is being combined with water in order to make glucose and in order to make oxygen. So this is our equation for photosynthesis. And so the chemical equation is supposed to be make it quick and easy in order to read and understand what exactly is going on between a certain chemical equation. All right, and so where we're headed, all right, is we're going to be looking at, all right, the reactants, which would be this side, okay, we're going to count up the atoms and the mass on this side, and we're going to make sure that it's equivalent to our products over here, all right, our products. And we're just going to confirm that everything matches up. So in this case, all right, we look at our reactants and our products, we can add up. We have, remember, if there's a 0 there or there's no number, it's got to be a 1. All right, but we go coefficient multiplies to both. So 6 times, so for carbon, we would have 6 times 1, which would be 6 carbon. For hydrogen, we would have 6 times 2, which would be 12. And then for oxygen, we would have 2 of them, right? We'd have 2 of them. So we'd have 6 times 2 is 12. And then we'd have 6 times 1 is 6. So we would get, that's a terrible 6, we'd get 18. All right, and so we just got to confirm on the other side, all right, do we have that? Do we have those ratios? Do we have those numbers? All right, so again, we got our carbon, our hydrogen, and our oxygen. And so we're going to have carbon is equal to 6. We got 6 here. We got 12 hydrogen. That's the only place we have hydrogen, so we can put that down. And then we have 6 oxygen plus 6 times 2. 6 times 2 is going to be 12. All right, 6 plus 12 is going to give us 18. All right, we're going to go through a bunch more examples, so don't freak out too much if you don't know exactly what's going on yet. But this is kind of where we're headed and what we're trying to do with this video. All right, so moving on, next page. There we go, reactants. So here, we're just breaking down and understanding that reactants are going to be our ingredients. Okay, they're going to be the thing that we use to create the other side, the products, which are on the other side. All right, so anything on the left side is going to be a reactant. Now, if I were to flip the arrow, then the reactants would always be on the side that the arrow is coming from. Okay, it's the beginning of our reaction, and it combines these two things to create our product. So this would be the cake on this side, all right, whereas the other side would be the ingredients of that cake. All right, so let's go find out more about that cake, the reaction piece. All right, the product side. So if we look at the products, they're always going to be on the right side or wherever the arrow is pointing. This is going to tell us our results of our reaction, and it's going to tell us all the new substances that are formed in a chemical reaction. All right, so let's keep on keeping on. So wrap strategy, that's one way to memorize exactly what's going on. But in the wrap strategy, we have our reactants, we have the arrow, and we have the product. And for the most part, this is always how you're going to see it. You're going to see reactants on the left, you're going to see products on the right. Now, I will warn you that arrow can switch. We're not going to do that to you here, but just keep that in mind that it can switch in the future. But again, wrap, reactants. Okay, these are our ingredients. These are the things that are combining together to create our products. So we have iron oxide and we have carbon. They're going to combine together to make pure iron and make carbon dioxide gas. Okay, for the products. This is the result. This is our finished product, whatever we're baking. And so let's keep on going. All right, law of conservation of mass. All we're talking about here, guys, the definition of mass is going to be the amount of atoms inside something. Okay, so all of us have a certain amount of mass. All right, it cannot be created or destroyed, any of this mass. The atoms cannot be created or destroyed. So that means we should have the same amount of atoms or mass going into our reaction that we have going out of our reaction. So if these two do not match up, if they do not equal each other, we're in trouble. All right, we know that we did something wrong. There is something that went wrong in our calculation, and we have to abide by that rule because we know there has to be conservation of mass. It's one of the laws of the universe. So we need to use that. All right. So the best way to do that is add up all the mass on the reactant side. So in this case, 40 plus 60, and we get 100. All right, we get 100. Whereas over on this side, we add up all our products and we get 100 here, so it's equal. So we're good to go. All right, and that's simple. That's as much as the conservation of mass is. That's all it is, guys. All right, here we go. Let's keep on going. So balanced and unbalanced equations. Very, very similar to conservation of mass. They're actually related. But basically what we need to do is we need to count the atoms and make sure we have the same amount of atoms in the actual equation as we do for the products and the reactants. Okay, and so we need to find the number of atoms, which we are getting better at. We're pretty good at now. For each element, that's what we did at the very beginning of this video, is we wrote the carbon, the hydrogen, and the oxygen on the side. I highly recommend you do that, especially when you're trying to solve problems on your own. And then we're going to find the number of atoms of each element on the product side. Again, we're doing reactants, products. Are they equivalent to each other? If they are, good. If they're not, then we know something is not balanced. Okay, it's not balanced. If they're not equivalent, it's an unbalanced equation, and that means that some changes need to be made. Something went wrong. Okay, something went wrong.